Hello, my beautiful computer science students. Welcome to another AP CSA lesson where I, Goldie, take you through Unit 3, Boolean expressions and if statements. Today's lesson, we are going to be going over simple ifs. So we're going to be talking about conditional statements and evaluating conditional statements with just a simple if statement. So let's get right into it here. We have conditional statements to be able to allow our program to make and adapt based on what's happening in our program, okay? Whatever's going on in our program. To make a decision in our program, we use what's called a conditional statement. Conditional statements basically ask a question in your program, and if that statement or if that question is true, the block of statements is run, and if the question is false, the block of statements is skipped. Okay, so you ask a question, and the answer to that question is either going to be a yes or no. Just two possible outcomes, either yes or no. And based on that outcome, a code segment is either run or not run. Conditional statements affect what we call the flow of control. So up until this point, we've said that code runs from top to bottom in order, one by one. We've gone over methods and other classes where those segments of code are not run unless they are called on. So your program starts off running top to bottom. If we have a method call, it'll go to that method, it'll execute that code, and then it'll come right back to that line and keep executing from top to bottom. Now with conditional statements, what's going to happen, you're still going to go top to bottom, but if you get a conditional statement and something is false, you might skip lines of code. Okay? So that's what you're going to see with the flow of control now. We might be skipping lines of code based on a Boolean condition. A Boolean condition is that question that we're going to ask. It's a statement, but it's the question we're going to ask that's going to evaluate to true or false. The Boolean condition will be placed in parentheses following the conditional statement that is asked. So there's going to be a couple of different types of conditional statements. We're going to go over just the if conditional statement today. Okay. So an if statement checks if a conditional statement, if this Boolean statement is true or false. If it's true, the body of the if statement will execute. If it's false, the body will be skipped. And here's the syntax for it. So you see we have if, lowercase if. By convention, usually we put a space between the if and the parenthesis, but that space is optional. Okay, so you'll see some people not put the space between there. It's up to you what you feel comfortable doing, but usually we put the space there just to separate it. And then we have in parentheses some sort of condition. So I just put the word condition, but there's going to be a condition in there that's going to evaluate to true or false. Okay. And then when we talk about the block of statements in the if, we have an open and closed curly brackets to represent the block. Okay. And then inside those curly brackets, those are going to be your statements. And those statements inside that block are only going to run if that condition is true. If that condition evaluates to false, then that entire block is then skipped. So this is a one-way selection. So it is just one way to select that what's in the body, right? If the condition is true, it'll run. If it's false, it will not run. The body itself, there might be many lines or even other if statements or other types of things inside that if statement that might end up running if the statement is true. Okay. Other lines in the curly brackets still need to end with semicolons, okay, unless if it's another if statement. If there's only one statement in the conditional, the curly brackets are optional. Okay. So if you just have a single line inside the if statement, those curly brackets are optional. You can still have them, you don't have to have them. If there's more than one line, you do need those curly brackets. Okay, so we're going to jump into a few examples and I'll show you exactly what we mean by condition being checked and some examples of those curly brackets being used. Okay, 3 examples here in the notes in each column here. We're going to focus on the first one to the left here. Okay, where it says int x equals 5 on the left. So trace the following statements to determine the value of x after the code has executed. So we start off here, int x equals 5. Okay, so perfect. Variable x is 5. And then here we have the conditional statement. Okay, so you have if x less than 6. Okay, so that is going to evaluate to a true or a false. Okay, in this case it's true because the value of x is a 5. 5 is less than 6, and because that's a true statement, that means that the line of code inside that block is going to run x plus plus. We know that x plus plus means that a 1 gets added to the x, so x becomes 6. Okay. And then I reach the end of my if statement and it has run. Then I have another if statement here that also needs to be checked. It says if x equals 6. Equals checks for equality. Does 6 equal 6? That is true. That's a true statement. Okay. Because it's true, that next line of code inside those brackets will run. X gets the value of 3 added to it and then gets stored back into x. So x becomes 9. So 9 is the value of x after the code has executed. Okay. So both of those show the if statement being used. I didn't put the space here. Okay, so you can see with the type of font I'm using, it's kind of like pushed up right next to each other. Again, that space is optional. And then I did where we do the block, the curly brackets on their own line. Again, that's kind of a style thing. That's totally up to you. You'll see it both ways. Okay. This next one, I do the end of line curly bracket. So you can see we start off x is 10. And then you see my first bracket there is at the end of the if statement. Very similar to how I do my methods in my classes, okay? Just to kind of save space almost on the screen. But you'll see it both ways, okay? Just like you'll see methods written both ways. So this x is 10 now for this example. And then it asks the question, if x is greater than or equal to 14, okay? Is x greater than or equal to 14? No. 10 is not greater than or equal to 14. So what happens? That all of the statements in that if block, and there's only one statement right now, but the statement gets skipped. Okay, so that never happens. X never gets 3 added to it. Okay, we immediately go on to the next line of code. So that's the flow of control, right? It goes top to bottom. If this is false, we actually skip that line of code, and then we continue on with the program. So we go to the next if statement. If x is less than or equal to 6. So in this case, is 10 less than or equal to 6? That is again false. Okay. 10 is not less than or equal to 6. So again, that line gets skipped. We go to the last if statement here. If x is equal to 10. Is 10 equal to 10? That's true. We finally reach a true statement, and then that line in there is run. So 10 plus 2 is 12, gets stored back in x. The value of x after this code is 12. Okay. All right, and our last example here, you see an example of no curly brackets being used, because with this if statement right here, there's only one statement that goes after it. Okay. We indent it just to try to make it easier to read. The indent is optional, but you'll definitely want to include it just so your eyes can actually see what's happening. Okay, but those curly brackets are optional when there's just one statement in there. Okay, so here x starts off as 5 again, and now we have an operation. Okay, it says x divided by 3 greater than or equal to 0. So we'll talk about how operations are evaluated first in order precedence, right? So we've talked about PEMDAS, right? Parentheses before multiplication, division, all of that stuff with just regular operations. When we start adding comparison operators, the operators themselves, like multiplication, division, modulus, add, subtract, all of those are evaluated first. The comparison is done last. So here, when we say x divided by 3 greater than or equal to 0, the x divided by 3 is evaluated first. What is x divided by 3? That's going to be 1. okay, because those are both integers, so we do integer division. 5 divided by 3 is 1. Okay. Now this doesn't change the value of x. Okay, be very careful with that. X isn't changed. X is still 5. We are just evaluating an expression to get an answer. Is x divided by 3 greater than or equal to 0? Well, since it's 1, 1 is greater than or equal to 0, it's going to be true. Okay, it's true. X doesn't change with that condition. It's just asking a question. And it's true. Because it's true, now we go into the block and x gets changed. X gets the value of 2 added to it and then stored back into x. Okay, x plus equals 2. Okay, with me? So this next one, again, x minus 10 greater than or equal to 0. That's done first. 7 minus 10 is negative 3. Okay, so the operator, again, is done first. 7 minus 10 is negative 3. Is negative 3 greater than or equal to 0? It's not. Because it's not, the answer to this statement is false. This question is false. So that gets skipped. And we end with x being 7 still. Okay. So we got our first taste of those comparison operators. So here's a little table to kind of help you see them. Hopefully they're pretty self-explanatory. You know, we just don't have you're used to in math the less than or equal sign, but we don't have that on the keyboard. We can only use symbols that we find on the keyboard. So less than or equal to is just less than with the equal to right after it. Same thing with the greater than or equal to. And then we have the equal to. Okay, this checks to see if two values are equivalent to each other. We can't use just the regular equal sign because that's an assignment operator. Okay, we use regular equal when we just want to assign. When we want to compare two values, we use the equal equal. Okay, and then same thing with the not equal to. Usually you're used to this symbol right here, the not equal to, but that's not a symbol on the keyboard. So we use the exclamation mark and then equal. Okay. Let's look at a couple more examples. These are going to get a few more things we have to keep track of. Let me try to say that correctly. A few more things we have to keep track of here. So we're going to start off this example with the values of A, B, and C. 3, 2, 1. Okay? And then we're going to start comparing some of these. So if A is greater than B, okay? So the value of A is 3, value of B is 2. Is 3 greater than 2? That's true. Okay? Again, those conditions ask a question. They don't change anything about a variable. They don't do anything besides just ask a question. Is what is stored in A greater than what's stored in B? It's true, so C gets 1 added to it. Okay. This next question, again, the operation happens first. So B plus 3 is 5. And is that greater than 2? Okay. Again, B doesn't change. Okay. There's no assignment happening. B does not change. It's just asking, is B plus 3 greater than 2? So 2 plus 3 is 5. 5 is greater than 2. That is true. A gets 1 added to it. So this A plus plus, that's shorthand for changing the value of A. Okay. And then this last one. 5 greater than A plus B. So even though the operation is on the other side here, it still happens first. Okay? The comparison, the greater than, happens last. So when written out with the values of A and B kind of plugged in there, 5 greater than 4 plus 2. Okay? Well, 4 plus 2 is 6. And 5 greater than 6, that's false. Okay? So B gets skipped. We've reached the end of our statements. So the value of A is 4, B is 2, and C is 2. Yeah. Okay. So remember, your condition always has to ask a question. If we just had something like if B plus plus, and then we had some statements in here, sorry, curly brackets, that wouldn't compile. Okay, I forget exactly what the compiler would say, but it wouldn't compile there because you're not asking a question in here. Okay, this is not a question. It's trying to change the value of b. Okay? So if you don't ask a question in there, it's a syntax error and it won't compile. You have to ask a question with one of these comparison operators. Okay? Same thing if you just had if b plus 3. Okay? That itself, that's not a question. That's just b plus 3. Because it doesn't ask a question, you're going to get a syntax error. Okay? So always make sure you're asking a question. Okay. Second example, again, just trying to involve some more things to keep track of here. We have three variables, x, y, z, 20, 30, and 5. Okay. So let's trace through this and see what's happening. This first block, okay, you see you have that if statement, and then inside an if statement, you have another if statement. Okay? This is called nesting, or nesting conditionals. And we're going to get to more examples later on in this unit, but I just kind of wanted to throw this out there just to show you that you can handle it. Okay. What'll happen, flow of control, first line gets evaluated, right? X mod 2 equal to 0. X is currently 20. So is 20 mod 2 equivalent to 0? Okay. That is true. 20 mod 2 is 0. There's no remainder when you divide 20 by 2. Because that's true, you then move into the if block and you reach another if statement inside. Okay? So this if statement asks another question. Is 30 mod 2 equal to 0? And since 30 is evenly divisible by 2, the answer to that question is true. And because that's true, then you move inside that if statement. And you get to this statement where x is changed. X gets 1 added to it and becomes 21. Okay? And then you've reached the end of that statement, reached the end of that, okay? And then you move on to the next line. Okay? So because those were true, you just kept going. Okay? Flow of control. If it's true, you just keep going. If it's false, that's when you get to skip your block of ifs. Okay? This next if statement, if x divided by 5 greater than or equal to 4. 21 divided by 5. 21 is an int, 5 is an int, so we do integer division. 21 divided by 5 is 4. Integer division, it's 4. So is 4 greater than 4? Hopefully you're saying no, it's false. 4 is not greater than 4. Okay? So because of that, that statement gets skipped. Okay? So it's a false statement. We skip that and we move on to the next if statement. Okay? So now we have two operators here, the mod and the plus, and then I have a comparison. Okay? So my operators happen first. Remember, mod happens before addition because mod is the same precedence as like multiplication and division. So this is the statement with y plugged in. So 30 mod 3 is going to be 0 because 30 is evenly divisible by 3. There's no remainder. So that's going to be 0. 0 plus 1 is 0. So we're asking the question, is 1 equal to 1? And that's true. Okay. Because it's true, we move into the if statement, and 5 becomes 6. So at the end, x is 21, y is 30, and z is 6. Okay, some great examples. We have two last examples in this lesson here. Our next example is going to be working with strings. Okay. Let's see a fun example of strings. We're going to trace through this right now on your screen, and then I'm going to switch over to my Replit screen and show you some things you can do with this when you're actually coding. So I start off with 3 declarations. Holiday is Halloween, favorite is Christmas, and count is 0. Okay. So those are my 3 variables I'm starting off with. And then I ask a question. Okay, so I see my question because I have a comparison operator here, and I want to see if holiday.length is greater than favorite.length, because those are 2 strings here. Okay, well, holiday.length is 9. There's 9 letters in holiday, and there's also 9 letters in Christmas. Okay, so is 9 greater than 9 is the question. It's not. It is false. So because it's false, count gets skipped. Okay? So you can use strings to also ask a question. All right? This next one, dot index of. Okay, so holiday dot index of L. That's supposed to be an L. It looks like a 1 because of the font, but it's an L. So holiday, that first L occurs on index 2. Favorite index of S occurs on that last index of 8. Okay, so index of L is 2, index of S is 8. So the question is 2 greater than 8? False. Okay, 2 is not greater than 8, so that line gets skipped. Okay, so after those two if statements, count is still 0. All right. Our last one, holiday dot compare to A. Okay, so holiday dot compare to A. When you're comparing a word to a letter, okay, you look at, you compare the first letters first. If it's the same letter, you move on to the next letter, etc., etc. But because capital H and capital A are different, we are going to compare the H and the A. Okay, so Halloween versus A. H comes after A in the dictionary, right? The dot compare to was lexicographically. So where do they relate to each other in the dictionary? So because H comes after A in the dictionary, you're going to have a positive number. Okay. Now I told you it doesn't matter. Doesn't matter what that number is. Okay, don't worry about that number. I explained it in the last unit, but you don't have to worry about that number for the AP exam. Just worry about, am I going to get a positive, negative, or 0? You will get a positive number in this case because H comes after A in the dictionary. So because a positive number, whatever that number is, since it's going to be greater than 0, this is going to be a true statement. Okay. So the count plus 3 happens. Count gets 3 added to it, stored back in count, and then we reach the end of our statements here. So count is 3. Okay. So I do want to take a moment and switch over to my Replit screen here and show you those examples worked out, right? So here's our example, Halloween, Christmas, count is 0, all 3 of those if statements. And then at the very bottom, I have a print count because I want to actually print the value of count and show you that you should get a 3 when you print that off once it runs. And there it is. You get your 3 printed off. Okay. What I also want to show you here is when you have if statements, like let's say you were confused about this when you're coding, and you're like, gosh, is holiday.length greater than favorite.length? Does count get changed here? Because all this happens when I have this system.println down at the bottom, it prints the value of count after all 3 of these if statements have run. But what if I'm like, does count change here? Okay, does it change here? Maybe I have some more complicated code and I just want to see what happens. This is where you can do sort of a analysis by taking that print statement and putting it in here. What you're doing is saying, okay, if holiday.length greater than favorite.length is true, count will increase by 1, and then it'll print off the value of count. Okay. If it is. Da, da, da. Now we know that's false when we traced it through, so I should still only get this print line statement that runs, just the bottom one, okay? Just the 3, and I do. Okay, this never ran because this is true, or excuse me, this is false, so it never ran. Okay, if I had, we knew that it was 9 and 9, so if I have greater than or equal to, now I should see count print off a 1 and then count print off a 3, okay, because this line will run after count increases by 1. And then this will run, oh sorry, it's not going to be a 3 anymore because count increased by 1 here, so it'll print off a 4. Okay, so you can use this, the if statements, put in system.out.println statements inside of your if statements if you want to test to see what's running. Okay, which is very useful when you start writing your own program and you want to see what happens. Does this code segment get run? Does this value get changed the way I want it to get changed? Putting in those print line statements really help. Okay, what you'll also see people doing is even just writing like stuff like here. Okay? Coders will write stuff like this to kind of flag if a code segment is reached. Okay? So if the here gets printed off, that means that if statement got printed. Okay? So just a few things you can start doing when you're actually coding these if statements to help you sort of understand the flow of control, especially as you're learning it, because it can get a little tricky at times. Okay, this is our last example for this lesson, our last example. Let's work with doubles. So we have double value equals 2.5. Perfect. Value less than or equal to 3. So is 2.5 less than or equal to 3? That is true. Okay, you can compare doubles and ints. They work just like a number line would work. It's a true statement. You're going to have -1 times value, which means that 2.5 becomes -2.5 and gets stored back in value. Okay. Then you have the next question. Is value greater than or equal to -4? Okay. Always be careful with your negatives. Okay. Is -2.5 greater than or equal to -4? Okay. If you have trouble with negatives, think of a number line. Okay. This is a true statement. Okay. -2.5 is greater than or equal to -4. So we have a math.absolute value. So -2.5 becomes +2.5 again. Okay. Our last if statement. If value divided by 2 greater than or equal to 0. Okay. Now we have a double divided by an int here. Okay. And remember, when you have a double and an int, the int gets promoted temporarily and it becomes a double division. Because you have double division, the result of that is 1.25. Okay. So never forget that when you have mixed expressions like that. 2.5 divided by 2 is 1.25. 1.25 is definitely greater than or equal to 0. That's true. So value gets 1 added to it. When you have a double and you have 1 added to it, it's just the same as it always is. 3.5 is now your value. Okay. So just trying to remind you of a couple of small things in there with that example. But that brings us to the end of our computer science lesson on simple ifs. So I appreciate you guys watching and following along, and I will see you next time.